My name is Elliot Strand, co-founder of Page Technologies, where our mission is to revolutionize environmental monitoring with distributed sensor technology. So here I'm showing a map of the state of Pennsylvania. So why are we looking at this map? That is because Pennsylvania consists of about 12 million hectares of land, which is how much arable land our planet is losing to grow food on every year due to soil degradation and urbanization. A recent report from the White House came out that stated that we cannot simply rely on more land, water, or energy to boost productivity. We need to harness the power of innovation. And one innovative solution is through controlled environment agriculture. By growing food indoors, farmers can use 90% less water, 7 times less land, and can grow 24/7, 365 days a year in any environment, such as in the middle of a city. But there's a problem within the indoor agricultural market. Right now, growers are forced to send hydroponic fluid samples to labs to get a better understanding of how they should fertilize their growing fluid. This process is not only expensive and costs about $200 million each year in the US, but is also quite labor intensive and takes about 10 to 14 days to receive the data, which makes it very difficult to make effective decisions. Our technology is the solution to this problem. We use printing processes similar to how magazines or newspapers are made to manufacture high-tech chemical sensors at extremely low cost. Our sensors can be plugged directly into traditional readout electronics for both handheld and wireless data capture, as well as incorporating a software data analytics app to provide the affordable real-time data that our customers desperately need. Through extensive customer discovery, we've identified through hundreds of customer discovery interviews through both the regional and national ICOR programs. We've determined an ideal product market fit within this space. By adopting Page's solution, indoor growers can increase their revenue per farm by about 140,000 each year, mainly due to increased yields, reduced labor, and reduced fertilizer costs. We've been gaining a ton of traction in this market. We've already established partnerships with both end users who want to pilot our technology, as well as distributors who want to sell our products across the market. We're also very excited to bring our technology into parallel markets and partner with big players such as Syngenta to test our technology at their new soil health testing facility located outside of Fort Collins in Colorado. When comparing our technology to others on the market, there simply are no other solutions that can offer both real-time data at our price point. In other words, it only takes a few dollars for us to manufacture our sensors, and it takes about 10 seconds for them to receive the data. While our go-to-market strategy is focused on hydroponic testing within the US, we have a platform technology and can measure a variety of different parameters in various environments. And we envision a world where Page's sensors are distributed everywhere to be used for various applications such as outdoor agriculture, in-field carbon sequestration, wastewater treatment, as well as environmental protection to mitigate issues such as nutrient runoff due to over-fertilization. Our team was born out of a 4-year research partnership between the University of Colorado Boulder and the University of California, Berkeley. My co-founder, Peyton, and I invented the technology, and we have an exclusive option agreement in place with CU Boulder and are finalizing a term sheet with UC Berkeley to license all of the relevant IP. We'll also be developing additional IP as we continue to develop the technology for commercialization. We also have an elite team of advisors who have all started their own companies, both in the ag tech and water monitoring markets, and have really accelerated our path towards commercialization. Here's our upcoming roadmap. We used the Lab Venture Challenge First Place Award to construct and demo our proof of concept prototype at the Indoor AgCon trade show in Las Vegas. We recently secured a $250,000 non-dilutive grant from the state of Colorado, which we're going to use to hire our core engineering team, conduct a series of pilot tests to optimize our product market fit, and launch our first product line at scale in Q1 of 2026 before scaling up. We're going to be offering a subscription plan that combines our hardware and software platform into one subscription, and it's very customizable and can be tailored depending on our customer and depending on what types of parameters they want to detect and what kind of features they want on the analytics side. We also see opportunities to enter into consumer markets, folks such as hobbyist growers who want to get a better understanding of the real-time chemical composition of their local environment. Here's our revenue forecast over the next 3 years. We're going to start with paid pilot tests with our first pre-seed round, and we're also going to be partnering with distributors who already have the distribution and sales channels in place to quickly spread our product across the market. And I just want to highlight that this forecast actually only accounts for penetration within the indoor agricultural sector, but we actually anticipate in entering parallel markets during the first half of 2027. Right now, we're raising 500,000 to fulfill the 2-to-1 match requirement for the $250,000 non-dilutive grant from the state of Colorado. This will provide us an 18-month runway to conduct pilot tests and secure our initial revenue. And we also were approved recently by a tax credit from the state of Colorado to our investors as well. And with that, I just want to say thank you all so much for your attention, and I am more than happy to answer any questions. Thank you.
So of the sensor data that is typical for these farming operations, what percentage or how vast is your reach as far as the sensors that your company is producing?
Yeah, so typically in the indoor ag space, especially and outdoor as well, EC or salinity is very commonly measured, as well as pH and temperature, which we've done all of that at lab scale. But the novelty is that we're focusing on, like, our first product line will be pH as well as NPK macronutrients, so your nitrate, potassium, and phosphate, which just there just really isn't hardware that's a reasonable price that can measure those specific nutrient concentrations.
And so for pH and NPK macronutrient test sensors that you're developing for those measurements, how accurate have they proven to be, like, in your testing so far, or have you not tested them yet?
Yeah, it's a great question. Yeah, we've tested them in active growing media. Right now, we're at about 15% accurate compared to ground truth lab measurements. It's difficult with soil since you can send a sample to 10 different soil labs and you're going to get a slightly different parameter, kind of, what the ion concentration is per lab. But we've been focusing on hydroponic testing and we're at about 15%. We want to get it down to 10%, which I think we can do through innovation. But a lot of the growers that we've spoken to are happy with 20%. They just want the data instantly and not have to wait, a couple weeks to receive the data.
Hey, Elliot, where are you?
Yeah, I'm in Boulder, Colorado.
Let's go Buffs. Thanks for the presentation. Is your a monitor disposable, the little red thing we're looking at, or is that actual reusable firmware, or what is it?
Yeah. So that kind of image on the far left of the top right quadrant, that is kind of an example of a printed sensor strip. And that can be used. So far we've done stability measurements, and it can be used for continuous monitoring for up to a month of fully exposed in the growing environment. So it's not a single use measurement.
A quick question, like, we've seen the first wave of the indoor ag, ventures that really have struggled to sustain and, be profitable. Like, we've seen a lot of aero farms and other companies really struggle and currently, shut down. But I think this is really going to be interesting to see the second wave of the control environment agriculture startups, which most of them are going to be your customers. So I'm just kind of curious to understand, how are you protecting yourself? How are you creating that moat that would give you that sustained competitive advantage? And can you speak to that a little bit? And you mentioned here some IP protection. Is that approved, or, like, where do you stand with all of that?
So yeah, great question. So the novelty, the kind of, special sauce, if you will, of our technology is, both how we manufacture the devices. So using these very scalable, low cost printing methods, as well as the device architecture. So kind of what, that image on the left kind of shows a couple layers, but there are a few other layers that go into our device to get it to have very similar performance as commercial sensors. And that's the part that we have protected in these various patent applications. Right now, they're all mostly at the PCT stage, so they're patent treaties, so haven't been fully approved by the USPTO as of today. And just to kind of comment on the indoor ag space, it's definitely shifting a lot. I think there was a big heat. There's kind of two segments of that market, both kind of smart high tech greenhouses as well as vertical farms that use artificial lighting. And those are the ones that have been really struggling. And a big problem is the lack of labor. Just having highly skilled growers that can really have the know-how to operate those, in a positive profit way. But it's really leading in towards automation is really what we're seeing, and the ability to be, for example, to automate their fertigation system to, perfectly dose their nutrients based on real-time nutrient data is really where we're seeing it headed. Kind of like a turnkey system where you just, you turn on the system and it just grows, and there's very little input from a user. Is I think where it's heading.
So, round of applause for Page Technologies. Now, round of applause for all our startup pitches today.